January 2026. Beneath the border of France and Switzerland, nearly 100 meters underground, a machine stretches in a perfect circle for 27 kilometers. Steel, magnets, superconducting coils colder than deep space. The Large Hadron Collider does not sleep. At least not yet. A physicist walks through the tunnel corridor. The air hums softly with the sound of cryogenic systems. Every step echoes against metal and concrete. Above him, cables run like arteries through the ceiling. Millions of proton collisions are happening every second. Invisible, unimaginable, silent to the human ear. And somewhere inside that flood of data, a subtle irregularity has appeared. Not an explosion, not an alarm, just a deviation, small enough to ignore, but precise enough to disturb anyone who understands statistics. Tonight, something is different, and no one knows why. Two beams of protons travel in opposite directions, guided by magnetic fields so precise they bend reality at microscopic scales. When they collide, energy converts into matter. For a fraction of a second, the universe resembles what it looked like just after the Big Bang. Particles flash into existence, then decay. Most of these events follow predictable pathways, known signatures, familiar patterns. But in January 2026, an AI system monitoring decay channels flagged something unusual. A statistical drift. Not dramatic, not chaotic, just shifted. A pattern that leaned slightly left when researchers were present in the control room, and leaned right when the room was empty. Should not matter. Human presence should not affect subatomic events sealed inside vacuum chambers. And yet the curve moved, quietly, persistently. The control room is never silent. Monitors glow with cascading numbers. Graphs redraw themselves in real time. Software models simulate trillions of interactions. When the anomaly first appeared, it did not trigger panic. It triggered curiosity. A few researchers leaned closer to their screens. They reran the analysis, then ran it again. One scientist cross-checked environmental logs. Temperature stable, magnetic field stable, power supply stable. Another checked calibration reports. No obvious fault. But when the data was segmented by time and cross-referenced with room occupancy logs, something strange emerged. The inversion was consistent. Day shifts produced one distribution. Automated night cycles produced another. No alarms, no public statement, just a quiet tension building behind rows of glowing monitors. In particle physics, randomness has structure. Decay channels follow probability distributions refined over decades of experimentation. When those distributions shift even slightly, physicists notice. The AI system had been trained on years of baseline data. It recognized subtle variations invisible to the human eye. The flagged anomaly showed a deviation in specific decay signatures, small, but statistically persistent. Not 5 sigma discovery level. Not a breakthrough, but not noise either. What made it unsettling was the inversion pattern. When humans were physically present in the control room, the curve skewed one way. When the room was empty, it skewed the other. Correlation does not imply causation, but it does demand investigation. And in physics, investigation means repetition. Could human presence influence the system indirectly? That is the first rational question. Humans generate heat, electromagnetic interference from devices, vibrations from footsteps. Even small environmental shifts can matter in ultrasensitive experiments. Engineers began reviewing ventilation logs, power harmonics, microseismic activity. Nothing obvious stood out. Still, extraordinary claims require extraordinary evidence. No one was suggesting consciousness altered quantum fields. That would be reckless. But the alignment between occupancy data and statistical drift was difficult to ignore. Perhaps the machine was simply more sensitive than previously assumed. Or perhaps the AI was detecting patterns in noise, something machine learning systems are notoriously good at. The line between anomaly and illusion is thin. As days passed, the anomaly did not disappear. It remained subtle, persistent, quietly repeating across multiple runs. Internal discussions grew more intense, not about mysticism, not about hidden forces, but about measurement itself. Quantum mechanics has long grappled with observation, not conscious thought but interaction. Does measurement define reality, or simply reveal it? Inside the accelerator, trillions of particles collided exactly as physics predicted. And yet, within the data, a whisper suggested something slightly out of place. With only months remaining before the collider enters a 4-year shutdown, time is limited. If this is a systematic error, it must be found. If it is something deeper, it must be proven. Theoretical physics has always allowed room for the unknown. Beyond the standard model, there are proposals, extensions, speculative frameworks, hidden valley models, weakly interacting sectors, dark fields that barely couple to ordinary matter. Most of these ideas remain mathematical possibilities, not experimental realities. But anomalies are where such ideas are tested. If a deviation survives calibration checks, survives environmental review, survives statistical scrutiny, physicists begin asking uncomfortable questions. Not, is this consciousness? But, is there an interaction we are not modeling correctly? Is there a variable assumed irrelevant? That isn't? In complex systems, small overlooked parameters can amplify in subtle ways. The history of physics is full of surprises born from tiny deviations. But most deviations disappear. Artificial intelligence is powerful, but it is not infallible. Machine learning systems are trained on historical baselines. They learn what normal looks like. Yet large datasets generate patterns constantly, many of them meaningless. False positives emerge. Correlation clusters appear by coincidence. When billions of events are processed, statistical flukes are guaranteed. The anomaly in 2026 could be nothing more than overfitting, an AI detecting structure in randomness, a ghost in the algorithm. Before rewriting physics, the code must be questioned. Every filter, every training dataset, every threshold parameter. Sometimes the mystery is not in nature, it's in the model. Quantum mechanics unsettled science from the beginning. Particles behave like waves. Waves behave like particles. Measurement collapses probability into outcome. But nowhere in the equations does human awareness appear. Detectors interact. Fields respond. Information becomes physical. The role of observer has often been misunderstood outside physics. It does not require consciousness. It requires interaction. So if the 2026 anomaly correlates with room occupancy, the first explanation is not metaphysical. It is environmental coupling, subtle interference, complex system sensitivity. Reality does not bend to thought, but systems can respond to physical presence. The most puzzling feature was not the drift itself. It was the inversion. When researchers were present, decay channel distributions leaned one direction. When the room was empty during automated cycles, the distribution flipped. Not randomly, not chaotically, consistently. Engineers simulated thermal shifts. No match. They simulated power fluctuations. No match. They isolated magnetic interference variables. Still no definitive cause. This does not prove anything extraordinary, but it eliminates some ordinary explanations. And that is where tension grows. Because when simple answers fail, more complex ones must be explored. Physics has encountered anomalies before. Faster-than-light neutrinos later traced to a loose cable. Unexpected cosmic signals, later identified as microwave interference from a breakroom appliance. Anomalies are exciting, but they are usually mundane. The discipline of science lies in assuming error first, not discovery. If the 2026 pattern persists through independent review, replication, and blind analysis, then it becomes interesting. Until then, caution is wisdom. The collider has revealed the Higgs boson. It has confirmed decades of theoretical prediction. It does not require sensationalism. It requires patience. Human presence changes environments in subtle ways. Microvibrations from footsteps, airflow alterations, electromagnetic signatures from personal devices. Even body heat distribution can shift air density gradients. In ordinary systems, these effects are negligible. In extreme precision experiments, nothing is negligible. Perhaps the anomaly reflects system sensitivity beyond previous calibration. Perhaps the collider is detecting environmental complexity, not consciousness. The more sensitive the instrument, the more delicate the equilibrium. Precision reveals not only particles, but the fragility of measurement itself. Time is now the limiting factor. The scheduled long shutdown approaches. Upgrades will change hardware, replace components, alter conditions. If verification is not completed before the shutdown, replication may be impossible under identical parameters. Data archives remain, but real-time testing disappears. An unanswered anomaly risks becoming a permanent question mark in the dataset. Not dramatic, not catastrophic, just unresolved. Science dislikes unresolved questions, but sometimes it must live with them. If I had to propose a hypothesis, it would not involve consciousness. It would involve coupling, ultrasensitive detection thresholds interacting with subtle environmental variables not fully modeled. Complex systems often exhibit feedback loops. Variables assumed independent may interact weakly but measurably. The inversion pattern suggests environmental modulation, not metaphysical influence. Still, the persistence of correlation demands rigorous review. Speculation is easy, verification is hard, and physics moves forward only through verification. Statistically, the safest prediction is this: the anomaly will dissolve, a calibration artifact, an algorithmic bias, an overlooked interference source. History suggests that is the likely outcome. But skepticism does not mean dismissal. It means testing, repeating, challenging assumptions. If nothing remains after scrutiny, then the system improves. And if something remains, then a deeper conversation begins. In the end, this story is not about consciousness. It is not about secret discoveries. It is about measurement, about how we interpret patterns, about how easily correlation can tempt explanation. Deep beneath the Earth, protons continue to collide. Indifferent to speculation, indifferent to observers, the data will settle the question. It always does. And whether this anomaly fades into statistical history or becomes a footnote in future textbooks, science will move forward, quietly, relentlessly,